I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to see the topic Depth of Penetration for the course Electromagnetic Fields. So consider a wave incident on the conducting medium having electric field in y direction and magnetic field in x direction, and the boundary of the conducting medium is given as dark line in the diagram. And when the wave penetrates into the conducting medium, the x equal to 0 at the boundary of the conducting medium, and after that it increases positively into the conducting medium. So we can write the electric field as Ey is equal to E naught e power minus x by del into e power minus j pi by del. So here del is called skin depth and it is given by root of 2 divided by omega mu sigma. At x equal to 0, this Ey becomes only E naught, and this is the amplitude of the field at the surface of the conducting medium. So now del has the dimension of distance. So at a distance x equal to del, the amplitude of the field is given by magnitude of Ey is equal to E naught e power minus 1, and we can write it as E naught into 1 by E. And so Ey decreases 1 by E, that is 36.8% of its initial value, while the wave penetrates to a distance del, and this del is called 1 by E depth of penetration. So for an example, consider the depth of penetration of a plane wave electromagnetic wave incident normally on a good conductor such as copper. This omega is equal to 2 pi f. So 1 by E depth or depth of penetration can be given as del is equal to 1 divided by root of f pi mu sigma. So for copper, mu r value is equal to 1, but mu is equal to 1.26 mu h per meter, and the conductivity sigma is equal to 58 megamhos per meter. So putting these values for copper, the skin depth becomes del is equal to 6.6 into 10 power minus 2 divided by root f. So here del is called depth of penetration. It is a distance parameter, so measured in meters, and f is the frequency in hertz. So from this expression we can understand that skin depth is inversely proportional to square root of the frequency. So at 60 hertz, this del value is 8.5 into 10 power minus 3 meters. At 1 megahertz, the skin depth is 6.6 into 10 power minus 5 meters, and at 30 gigahertz it is observed that the del value is 3.68 into 10 power minus 7 meters. So at 60 hertz, the 1 by E depth of penetration is 8.5 millimeter, and the penetration decreases in inverse proportion to the square root of frequency. And similarly at 10 millimeter, the wavelength penetration is only 0.00038 millimeter or less than half micrometer. So this phenomenon is also called as skin depth. So depth of penetration is also called as skin depth. So for higher frequency, the field, it is damped out as it penetrates a conductor in a shorter distance than a lower frequency field. In addition to 1 by E depth of penetration, we can say that for other depths for which the electric field decreases to an arbitrary fraction of its original value. For example, consider that the depth at which the field is 1% of its original value. So this depth is obtained by multiplying 1 by E depth by 4.6 and may be called 1% depth of penetration. So phase velocity is given by the ratio omega by beta, that is angular frequency by the phase constant, and beta is equal to 1 by del. So the phase velocity of the conductor is given by V is equal to omega del is equal to root of 2 omega sigma mu. So here 1 by E depth is small, the phase velocity of the conductor is also small, and the velocity is a function of frequency and hence the wavelength. So the ratio of velocity of a wave in free space to that in conducting medium is the index of refraction for the conducting medium. At lower frequencies, the index of conductors is very large. And finally, we can write the lambda c of the conductor value is 2 pi del, since f lambda c is equal to omega del. So here lambda c and del are in same units of length. Hence the wavelength in the conductor is 2 pi times of 1 by E depth, and this values of 1 by E depth are 1% depth, wavelength, velocity and refractive index for a medium of copper are given for 3 quantities. It is interesting to note that the electric field is damped 1% of its initial amplitude in about 3 by 4th lambda in the metal. So the penetration depth is inversely proportional to the square root of the frequency. A thin sheet of conducting material can act as a low pass filter for electromagnetic waves. So this is the table for the copper value. So penetration depth, wavelength, velocity and refractive index is given for 3 types of frequency: 60 Hz, 1 MHz and 30 GHz. So assessment question: skin depth, 1% depth of penetration, relation between depth of penetration and frequency. Thank you.